Good morning, Algebra 2. Today we are reviewing exponent rules. We're going to start with this warm-up right here. It says simplify and label the parts of the power using the vocabulary terms base and exponent. Remember, at any time you can pause the video to see if you can do it by yourself. If you can't do it by yourself, that's why I'm going to go over it. So to simplify, I'm going to multiply together -2 and 5, which is going to be -10. Then we're going to multiply x times x times x times x, which is x to the 4th. And then when I multiply those together, we don't need the times symbol in between. We just put them next to each other. Now, the -10 is just a coefficient. That is not the base or the exponent. Let's see. We'll do x is the base. And 4 is called the exponent. So the -10 is just a coefficient. Number in front. The base has the exponent on it. The exponent is on the base. Those go together. This 10 is multiplied in front. It's separate. Now, you had exponent rules from Algebra 1 or even prior to Algebra 1. And we have to be really good at practicing these because we're going to apply them to harder stuff coming up soon. So the first is called the product rule. And I'm just going to make up a problem like x squared multiplied by x to the 3rd. So the product rule means multiplying like bases. We're going to multiply like bases. So we're multiplying an x squared and an x to the 3rd. So the base is x for both. That's our like base. When we multiply like bases, so I'm going to do an expanded version and then we'll look at the algebraic rule. When we multiply this, x squared is just x times x, multiplied by x cubed is x times x times x. And then we look at all that and we say, well, that's x to the 5th power. So using our algebraic rule, this is more like a shortcut that says if we have x squared multiplied by x to the 3rd, we can do x to the 2 plus 3, which is x to the 5. So when we multiply like bases, we add the exponents. Notice what we're doing to the bases and what we do to the exponents is different. Some people get the tricks, the rules confused, and you have to know that they're different. And then over here is just the rule in words, and then a few more examples. So the quotient rule. I'm going to start with making my own up. How about x to the 6 over x to the 2nd? So if I expand this, x times x times x times x times x times x over x times x. If we can factor it out, so if I factor this out, there will still be a 1 down there because there has to be a 1 on top and bottom. There has to be a 1 still. If I factor those out, I can cancel out things that I factored. So when I multiply it back together, I get x to the fourth multiplied by 1 divided by 1, which is just x to the fourth. So when we are dividing like bases, what we're actually doing is subtracting the top exponent minus the bottom exponent. So with my example, x to the 6 over x squared, I could rewrite it using this algebraic rule saying x to the 6 minus 2, which is x to the fourth. So that is a shorter way of doing it, but you have to remember the rules. Notice that dividing like bases, but subtracting exponents are different. And then over here is everything that I said in words, and then some more examples. In this example right here, we have a negative exponent, which we're going to talk about today as well. We have a negative exponent. So when we go and we do m to the fifth, and then we subtract the negative 4, that turns into addition. Next is power rule. Power rule is where you have a power, like a base with an exponent, x to the third, and then we raise it to another power. So x to the third squared is the same thing as x to the third multiplied by x to the third. That's the same thing as x times x times x times x times x times x, which gives me x to the 6. So the algebraic rule would be to take x to the third squared and rewrite that as x to the 3 times 2, which is x to the 6. So the power rule, if we are, how do I want to say this? If we are power of a power, then we multiply the exponents. So again, the power and multiplication are different things. Okay, raising a color do I want to use? Raising a product to a power. So here I would have perhaps 3x squared, and we're going to take that and we're going to raise it to a power, and let's raise that to third. So if we have a product 3 times x squared, I can rewrite this as 3x squared times 3x squared times 3x squared, which is 3 times x times x times 3 times x times x times 3 times x times x. I don't like doing this. This is a very long way of doing it. We can multiply 3 times 3 times 3, which is 27. X, 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 x to the 6. Okay, I have the correct answer, but there is a shorter way of doing it. If we raise it to a power, you can actually distribute that power to each piece. So if I have 3x squared to the third, currently my 3 has an exponent of 1. So what I'm going to do is I'm going to multiply the exponents but I'm going to do it to both parts of the product. So I'm going to have 3 to the third multiplied by x, and then I multiply these to the 6. And then 3 to the third is 27, and then x to the 6. Shortcuts. You should have done all of this before. Raising a quotient to a power. So this one is a lot like the one right above it. Let me make some things up here. Let's do, I don't know, x squared over y to the third power. I don't know why I'm doing so many threes. I'm trying to keep the numbers small so I don't have to write a bunch of stuff. So I've got x squared over y times x squared over y times x squared over y. And that becomes, we multiply straight across, we get x times x times x times x times x times x over y times y times y. Oh my gosh, that's so much work. There's got to be a shortcut. I didn't even finish it because I ran out of space. So what you can do is you can just take the n, the exponent, and give it to both the numerator and the denominator. So we're doing that by multiplication. Because anything with a power is going to multiply the exponents. I'll do that with my example here. If I have x squared over y, and that's to the third, that would be like y to the first. And then I'm going to multiply these, which gives me x to the sixth over y to the third. And that's what I had over there as well. Okay, anytime we have an exponent of 1, it just equals that number, exponent of 1. So that would be like, I don't know, 5 to the first is 5. What do we have over here? X to the first is x, 7 to the first is 7. Exponent of 0. This is a very forgotten rule here. The exponent of 0, anything to the 0 power is 1. So if I have 492 to the 0 power, that just equals 1. As long as we don't have 0 to the 0. We can't do 0 to the 0 power, but everything else works. All right, and then this one, negative integers as exponents. If I have x to the negative 1, this negative exponent, the negative 1 exponent, is directions, and it says, reciprocate me. That's what it says. It says to reciprocate. So we're going to reciprocate the base when you see a negative 1 exponent. So x to the negative 1 is the same thing as 1 over x. We reciprocate it. And you can see that example right here with a to the negative n. We do 1 over, and as soon as we do 1 over, that negative sign is gone. The n power does stay the same. So this is x to the first, but I don't really have to write the x to the first. Let me make up another example of that really fast. Let's say I have something like 3 to the negative 2 over y to the fourth power. If I have something like this, 3 to the negative 2 tells me that I am reciprocating the base of 3. So that tells me that I'm going to move that 3 squared to the bottom. The y to the fourth does not have a negative exponent, so it does not go anywhere. And if I move it down, there's always multiply by 1 on top, so we leave a 1 on top. And then I can simplify it to be 9y to the fourth, 1 over 9y to the fourth. One more of those, actually, we might have an example. I'll just go make one up over here. One more of those. Let's say I have x to the second over 4y to the third. Nope. Over 4y to the negative third. There we go. So I look very carefully and I see this y to the negative third. The 4 has an exponent on it of 1. The exponent of -3 is not on the 4. So when I go to reciprocate, I'm only reciprocating the y. And since it's on the bottom, I'm going to move it to the top. The x squared, it does not have a negative, so it stays. The 4 does not have a negative, so it stays. The y to the third moves up to the top and becomes positive when it moves up. Okay, that was like a lot of rules. Here's a graphic organizer that might help you remember what to do. I'm looking at in the center, I'm looking at what the operation on like bases would be. And we just went over all of this stuff, like power on like bases, or multiplying like bases, or adding like bases. So like multiplying like bases would be x squared times x to the third. Adding like bases would be x squared plus 3x squared, which we didn't do any of that today because that's not really what our lesson is about. Doing a power would be something like x to the 4th to the 7th, where we do a power. So these big words right here are following the order of operations. Like we always do exponents first, then we do multiplication, division, then we do adding, subtracting. So it's following that order. So that's how I know how to set it up. And then what we do to the exponents would be the thing that's underneath it. So if we are doing power, we do multiplication to the exponents. Or if we're doing multiply, then we do what's underneath it to the exponents. We do addition to the exponents. So this would be x to the 5th. And if we do addition, what do we do to the exponents? Nothing. So this would be 1x squared plus 3x squared, 4x squared. Nothing to the exponents. So the thing underneath is what you do to the exponents. So if we're doing a root, which we haven't learned yet, that's coming up in our chapter, we would divide. If we are dividing, which we did do on that first page, x to the 4th over x to the 2nd, we would do what's underneath it to the exponents, subtract them. So I would get 4 minus 2. Or if we're subtracting, let's say we have got 5x squared minus 3x squared. What you do to the exponents is underneath. Nothing. So 2x squared. So that's how that chart works. Remember, anytime the exponent is 0, we get 1 for the answer. And if the exponent is -1, it means to reciprocate. Okay, I'm going to go through a bunch of examples, and then you guys have a worksheet that are exactly like these examples. Hopefully this stuff will come back to you really fast. So the very first example, I'm just simplifying. By the way, I don't think I wrote words on or what the directions are. Simplify. There we go, simplify. So 5 squared would be 25, x to the 3rd, y to the 0 is 1, and then z to the 4th. We're going to combine that, and I'll have 25, x to the 3rd, z to the 4th. Number 2, y to the 0 is 1. So 28, x to the 3rd. Simplified. Okay, I've got like bases, like bases, like bases, like bases. When I multiply, I add the exponents. So I'm going to add 2 plus, there is a 1 right here, plus 4 plus 3. So I get x to the 10th. Okay, we've got a product. And in this product, we can do 2 times 3, and we can do m squared times m. So 2 times 3 is 6. But here I've got like bases, so I can add their exponents. There is a 1 on that m. So I get 6m to the 3rd. If I'm going too fast, you guys can always rewind or pause the video. Okay, for this one, all the numbers, everything's being multiplied here. All the numbers can multiply together. So -5 times -2 times 3 times -2. And then I will be multiplying a squared times a to the fourth, and then y times y. I'm going to start with the numbers. Let's see, -5 times 2, or -5 times -2 is 10, times 3 is 30, times -2 is -60. So my number is done. Here I am multiplying like bases. So I will add the exponents, and I get a to the 6. Here I am multiplying like bases. So I will add my exponents, which are 1 and 1. And I get y to the 2nd. Okay, question 6 has a power, but it is only on the thing in the parentheses, so it is not on the 3. So I will have a 3, and I'll multiply that by x to the 2 times 2, which is 3x to the 4th. So when we power them, we multiply. Number 7, the 3 and the x squared are inside the parentheses. So for this one, 3 is to the first power, and I'm going to multiply the exponent on the outside by the exponents on the inside. So we'll get 3 to the 1 times 2, x to the 2 times 2, which is 3 squared, x to the 4th, which is 9, x to the 4th. All right, the next one. This is a 0 power, which equals 1. And then this one, 3x squared. Both the 3 and the x have a power of 1. And then the power on the outside multiplies. So I get 3 squared x squared, which is 9x squared. I changed my color. All right, number 9, excuse me, is dividing like bases. The base is 10. This would be the exact same thing as doing x squared over x to the 3rd, only it's not an x, it's a 10. So when we divide, the rule is subtract the exponents. So I have 10 to the 2 minus 3, which equals 10 to the -1. Now, it is not simplified if we have a negative exponent. So we use the rule that says a negative exponent means reciprocate. So we take, reciprocate the base. So we take the base and we put it on the bottom. We keep the exponent of 1, and then that's 1 over 10 when we're done. Okay, for number 10, I'm going to look at reducing the fraction separate than the a's and separate again from the b's. So I'm going to separate each of these so that I don't get anything confused. So I'm going to look at -9 over 12, and I'm going to see if I can factor anything from the 9 and the 12. So -9 is -3 times +3, and 12 is 4 times +3. So I purposely picked 4 and 3 instead of 2 and 6 because I want these to cancel. So for the a's, we are dividing. So for the a's, I'm going to subtract their exponents. and I'm going to get a to the fourth. And then for the b's, we're dividing, so we're going to subtract the exponents, which gives me b to the negative 2. One more step for b to the negative 2. We can't leave it as b to the negative 2, so we have to reciprocate. So it becomes positive. This is going to be 1 over b to the positive 2. So now I'm going to combine all three parts back together, and we will have negative 3 and 4 on the bottom. On top, we'll have a to the fourth. On bottom, we'll have b squared. I made my line way too long. Okay, and on number 11, almost done. Number 11, let's see, that's a negative exponent, so I'm going to reciprocate. But that's the only thing I reciprocate. So currently this is over 1. So I will have 10 and y to the fifth on the top. X goes to the bottom and becomes positive 3. And that's it. Okay, number 12. I'm going to separate the numbers from the x's. So negative 15 over 10, I'm going to look for a factor. Negative 3 times 5 over 2 times 5. If I can factor out the 5, I can reduce it. And then my x to the 3 over x to the fourth makes x to the 3 minus 4, which is x to the negative 1, which becomes 1 over x to the first. And then we combine that back together, and we get negative 3 over 2x. The negative sign can be on the top, or the negative sign can be out front. It cannot be on the bottom. Okay, for this one, we've got a 4 to the first power. We have an x to the negative 6, and we have a y to the negative 4. So we reciprocate just the x and y. So we'll have 4 over, we'll have x to the positive 6, y to the positive 4. That's it. Okay, and then this one here, there's a few different ways that you could do it, but I'll go ahead and start with the numbers. Now 2 over 4, hopefully you can reduce that without having to do this next step, but I want to show you the next step so that you can see how it works every time. When we reduce, we can factor out a 2 from the top and the bottom and cancel them. And then these are dividing. There's 2 ways we could do this. These are dividing, so I am going to do subtraction. Another way you could do it is just reciprocate the 2 of them before doing the subtractions step. It doesn't really matter which order you do it. So I'm going to get x to the negative 3 plus 1, which is x to the negative 2, which becomes 1 over x squared. And then we put that stuff back together, and we get 1 on top and 2x squared on the bottom. So what I was saying is you could have done it where you switched the x to the first and the x to the third right away. You did the reciprocate right away, and then did x to the 1 minus 3, which equals x to the negative 2, which is still the same answer. And I believe that is it for the notes. Yep. So you have one worksheet. On exponent review. I should say exponent rules review. Have a wonderful day. If you got questions, email or Zoom with me to ask. Oops.